All right, so let's take a look at distances and midpoints. All right, so we've got an example here, and I'm just circling to focus your attention. We got 2 points, right? You need to do that in your notes. And what we want to do is we really want to find the distance between those 2 points. That's what we're after. So what is the distance between those 2 points? So I'm just going to take my blue here. I'm just going to draw a line between them. Right? I mean, that's what we want. We want that distance. And we'll call it D. So you guys, believe it or not, did this in maybe pre-algebra. Can't remember you guys back that far. Definitely in Algebra 1. You did it in geometry last year as well. So, yes, you did. Yes, I taught that course for 13 years. I know the course. You had it in geometry. So, what are you doing here to find the distance between those 2 points? What's the overall concept? There's a concept that allows you to do this if you can't remember the formula. So just a concept. Anybody know the concept? How are you going to find the distance between these 2 points? Anybody? How are you going to find the distance between those 2 points? It's concept. Come on, go for it. All you can do is be wrong, and look, no one else is going for it anyhow, so they don't know. They have no earthly idea. Take a shot. Any idea? Nobody? All right. Well, maybe you'll remember now. Look, what if you just simply make like a right triangle out of it? Do you now have the general concept of how to figure out the distance of that blue line? Can somebody now raise your hand and say, hey, use Julia? Pythagorean Theorem, right? So D is synonymous with C, right? And hopefully everybody remembers the Pythagorean Theorem, C squared equals A squared plus B squared. If you were to watch The Wizard of Oz, when the scarecrow gets his brain, he actually misquotes the Pythagorean Theorem. He kind of gets it wrong. He should say the square of the sum of the squares of the sides of a right triangle equals the hypotenuse, or the square of the sum of the sides of a, or the square of the sides of a right triangle equals the square of the hypotenuse. Something to that effect. He kind of goofs it up. But that's what he says when he gets his brain. Pythagorean Theorem. And hopefully we can all do this. You know, you look at this thing. All right, so what is the length of the red line? Well, I can count. You can count too, right? 1, 2, 3, 4, 5, 6. That's a 6. By the way, don't start at 1, right? It's the only thing that messes people up. I don't know why, but they want to say 1, 2, 3. Okay, you start. That's the first step is 1, all right? 1, 2, 3. All right. And then what are we going up? 1, 2, 3, 4, 5, 6, 7, 8. We're 8 up. And now everybody knows D. The value of D is? The value of D is? Come on, you know this one off the top of your head. The value of D is? Come on, the value of D is? It's okay. All right. 10. There we go. All right. Somebody knows a carpenter or a plumber or something like that, right? 3, 4, 5 triangle. Does that ring a bell now? The ratio of 3 to 4 and the hypotenuse is 5. Any kind of construction person uses Pythagorean theorem all the time because it gives you the ability to know that your walls are at a right angle, or whatever it is you're building that you want a right angle. Because again, 90 degrees, right? And so 3, 4, 5, remember similar triangles from last year? So if this is double from 3 to 6, and this is double from 4 to 8, then this is double from 5 to 10, right? Wonderful. All right, so it all starts with the Pythagorean theorem, but we have a distance formula. So before I do the next step, would you agree that if you were going to solve the Pythagorean theorem for C, technically you would take the square root of both sides, right? To get to C from C squared. So the distance formula, because it's going to be D and not D squared, we have a square root symbol. It's just a Pythagorean theorem. And so it's going to be the a squared, and leave yourself room with these parentheses, plus the b squared, right? The square root of the a squared plus the b squared. Well, how in the world are we going to find a and b without having to draw a picture and count the squares? Although if you can't do anything else, draw a picture and count the squares. So let's go down here and let's take this point here, right there, and let's say its coordinates, name its coordinates, and it's a -3, -2, right? And let's take the second point and give its coordinates, and its coordinates are a 3, 6. And then I'm going to come underneath and just say, we'll call this 1 on the bottom, right here. Let's call its coordinates x sub 1, y sub 1, right? The x coordinate of 0.1, the y coordinate of 0.1. Say, Mr. Scarfi, wait a minute. I want this point to be 0.1. Okay, fine. It works either way, all right? Doesn't matter. Whichever point you want. But call one of them 0.1, and therefore it's x of 1, y of 1. Call the other point 0.2, and therefore it's x sub 2, y sub 2, right? The x coordinate of 0.2, the y coordinate of 0.2. Don't let that be mysterious. It's not a big deal. All right, so how do you figure out the value of the side of the triangle without drawing a picture and counting? It's real simple. Do the final x sub 2. I'm going to use my red here in between because this is where you'll mess up if you mess up, minus the initial x coordinate, x sub 1. So it's just the quantity x sub 2 minus x sub 1 quantity squared. And if you remember that, you know what the back one's going to be, right? Y sub 2 minus y sub 1. And again, I'm going to do that minus sign in red, because if you're going to mess up, that's where you're going to mess up. All right, now we already know we're heading toward 10, so we better end up with 10, so we'll see if we do. So just for clarity's sake, let's sub in the coordinates. X sub 2 is 3. Got my minus sign still. X sub 1 is -3. So be careful. You got 3 minus a -3, right? And y sub 2 is 6. Minus for the formula. And again, I got minus a minus. Just be careful with those. Okay, so if you remember your order of operations, do inside the parentheses first. 3 and 3 is 6, so we have 6 squared. 6 minus a minus is plus, plus 2 is 8, so we have 8 squared. And let's save a step, so that's a 36, right? And that's a 64. Everybody okay with what I'm doing so far? I'm just, just doing the numbers. And you'll do the numbers too. And by the way, it's possible to have a negative. If you would have switched 0.1 and 0.2, this would have been a -6 squared. But what's a -6 times a -6? 36. You're going to get there either way. If you'd have flipped the points and called that 1 and this 2, this would have been a -8, but what's -8 squared? Positive 64, and it doesn't matter which way you go. All right, so we're almost there. D equals the square root of 100, and we all know that the square root of 100 is 10, because 10 times 10 is 100. And voila, we are there. You are there. Not hard. Pythagorean theorem, it's not hard. So to avoid drawing the picture and counting the squares, to use the Pythagorean theorem, use the distance formula, and that is right there. That's what you use. It's not that hard. It comes right from the Pythagorean theorem. It's where it comes from. The x2 minus x1 quantity squared gives you one side of the right triangle. The y sub 2 minus y sub 1 quantity squared gives you the other side of the triangle. The rest is Pythagorean theorem. Voila, you're there. Okay? Don't make that hard. It's not supposed to be. Just be careful with your roots and stuff. You'll always get a positive value because distance is always positive. So you're always going to end up with a positive value when you're done. And that's because you're squaring things before we take square root. Any questions on that? Distance. You got to know the formula, or you got to waste time to draw yourself a grid and count off of the grid. but you're wasting time, and that time is precious. On an ACT, SAT, that time's precious. That time that you take to draw that picture and count the sides is going to take away from a couple other problems. Lucas Gum, can you get rid of it, please? So, distance formula. If you know the formula, so much easier. All right, find the coordinates of the midpoint. Find the coordinates of the midpoint of the segment between -3, -2, and 3, 6. That's the exact same segment. So let me go back to the picture up here. We are looking for the point halfway between, right? We're looking for that point halfway between. You know, where is that halfway between point? Looks to me like it's at 0, 2, but is it really? I don't know. Well, you got a midpoint formula. The midpoint formula is real easy. If you notice, it's going to give you coordinates. That's why the parentheses right here, and that's why the comma. This is the coordinates of the midpoint. So that's what you're finding, right? Find the coordinates of the midpoint. So the formula is going to give you coordinates. And it's real simple, real easy. Just add up the x coordinates. You can go 2 and 1 again if you want. And it's going to be the average of their coordinates. How do you average two things? You add them up and divide by 2. So it's divided by 2. And the same thing with the y. You're averaging the y coordinates. So you add them up and divide by 2. It's all you're doing. Don't make this one hard. It's not supposed to be. You're just adding up the x coordinates, divide by 2. Add up the y coordinates, divide by 2. So if you were to work the formula, what do we got? A -3 is x1, and 3 is x2, divided by 2. And what about the y's? y1 is -2, y2 is 6, divided by 2. So -3 plus 3 divided by 2, that's the first one, right? The two x's. -2 plus 6 divided by 2, 2 y's. Hey, before I finish, I always like to do this. If I'm doing it without a picture and I'm just doing it right off of the problem, I just take a moment and say x1, y1, x2, y2, right? Same thing with figuring out the slope of a point. Because I don't know why, but sometimes people, when they don't label it, they do x1, x2. Okay, right? It's the x coordinate point 1, the y coordinate point 1. It's silly, but I've seen students do it over and over and over again. All right, where are we at? -3 plus 3 is 0. 0 divided by anything is 0. -2 plus 6 is 4. A 4 divided by 2 is a 2, and the coordinates of the midpoint are 0, 2. Do we like that answer? Well, if you go back, it would put the midpoint right there, and that surely looks like the midpoint to me, right? But again, you're not going to draw a picture. You're not going to take that time to draw a picture. You're simply going to run the formula, let the formula take care of itself. All right, so you got distance formula, you got a midpoint formula. All right, next. Put my shade up here. So 3 dimensions, distance and midpoint in 3 dimensions. So the real world is 3-dimensional. Now, if I were the one doing this, I would make this horizontal axis the x-axis. Because every other time, if it's not 3D, isn't that the x, right? Going off that way and that way is the x. Well, it's not now. Sorry. All right. And if I had my way, the one going up and down, I'd call the y. Because in the 2-dimensional plane, it's the y is up and down. I guess they want to confuse students, and that's not the y either. All right, so that's just the way it is. Although I will tell you this, if you go on the internet and you like Google 3-dimensional Cartesian plane, you can find the x, y's, and z's in all different places. But the standard is, it's just the way it is. This is the standard. That one's the x. This one's the y, and that one's the z. All right, sorry about that. It's just the way it goes. It's just the way it goes. That's the x, that's the y, and that's the z. And I will tell you this, a lot of times they don't show you the negative part of the axis. So this negative part's not included, this negative part's not included, and this negative part's not included. So a lot of times it'll only look like that with, again, x, y, z. They don't bother to show you the negative part of the axis. Now, it's really tricky figuring out the coordinates of a point. I mean, really tricky. So I did some parallel lines and a box to try to show you the coordinates of this point. So what would you call the x-coordinate of that point? Any idea? Just look along this axis and find something that makes sense. I think there's only really one value that makes sense, maybe two. You might either say 3 or like 1.5 are your choices, and it's really this value right here. So you look at the y-axis, and what would make sense on the y? What value on the y would make sense? You guys have it right in front of you. It's probably easier to see on your paper than here. What value makes sense for the y? It's actually 1, and the z is a 4. Coordinates of the point. It's hard to do. How in the world do you come up with -221 on that? Well, I'm telling you, it's to figure out the coordinates of the point is interesting to say the least, and a little bit mysterious. I will not give you a problem where I'll say, give me the coordinates. I won't do that. I don't know if you're going to get one on an ACT or SAT. I doubt it, because it's just too odd and strange. All right, so here's a 3D plotter. So let's plot the point. Here we go, 1, 2, 3. It's a little bit easier to plot than it is to figure out the coordinates of the point that's plotted already. So there's 1, 2, 3. Again, you can see the x is coming out you, the y is to the right, and the z is up and down, right? So here we'll hit plot. And you see it came out 1. I don't know if I can do it again. No. It went out 1 this way. It went to the right 2 along this axis, and then it went up 3. But looking at that point right there, are you going to figure out where it is? I mean, it's weird. Now, here's a little three-dimensional. When you go here, maybe... So, okay, so now you had to get it. Okay, the blue one is the x, so I can see it's in line with 1x. It's definitely in line with 2y. I have no idea how high up it is, right, on the z. Because, again, it's two-dimensional, medium, three-dimensional thing. So that's a little bit easier, and that way you can kind of figure it's up 3. But you can't do that with your paper, all right? There's no way. How about 1, -2, 3, so what happens there? Plot that one. All right, so that's symmetrical, but, you know, it's difficult to figure it out when it's just a point there. What you should know, what I expect you guys to know as a student is the first coordinate is the x-coordinate, the second coordinate is the y-coordinate, and the third coordinate is the z-coordinate. And for a normal 3D plane, the x comes out at you, the y goes to the right, and the z goes up. That's what I would expect you guys to know. Anything beyond that, you'll get into later on in life. If you're going to become a programmer and stuff, the real world is 3D. Right? I mean, things are in 3 dimensions in the real world, and you'll have to deal with 3D axes and all that kind of stuff. Okay, so let's use our brain. How in the world do we find the distance between 2 points in a 3D plane? So in other words, here, what's this distance? Ooh la la. All right, it's 3-dimensional. So if you were to guess, what would you guess? Come on, guess the formula. Throw it out at me. Throw it out at me. I hear x. How about x2 minus x1 quantity squared? Makes sense? Plus, say it. Y sub 2 minus y sub 1 quantity squared. We done? What do you want to do next? Plus z sub 2 minus z sub 1 quantity squared, right? Okay, there you go, 3D distance. That makes sense? You got to just care for that third point, that third coordinate. Oh no, how do we do midpoint in 3 dimensions? Surely we have no earthly idea how to do that. All right, let's do this one real fast. All right, so what do you want to call this? Point 2 over here? And call the other one point 1? Oh, I don't know what I just did. Come back. Come back. All right, so -2 minus 3 is a -5. So this is going to be a -5 squared, which is the same as 5 squared, right? 2 minus 1, that's a 1. That's going to be a 1 squared. And 1 minus 4 is a -3. That's going to be a 3 squared, right? -3 squared is the same as 3 squared. -3 times -3 is 9. So what do we get? 25 plus 1 is 26. Plus 9 is 35. Square root of 35. Okay, that wasn't so hard. We can do that. Even Oscar can do that. Okay, we can do that. All right, you had to be in leadership to know that one. All right, so distance is 35. And so what would you expect for the coordinates of the midpoint? Okay, well, math makes sense, not English. So it's got to be x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2, and z sub 1 plus z sub 2 divided by 2, because math makes sense. All right, so what are the x coordinates? A 3 and a -2. That's a 1, right? So the x coordinate is 1/2. And by the way, so you know, I'm looking here, right? X, Y, Z, X, Y, Z. What's the y? A 1. What's the y? A 2. 1 and 2 is 3. That one's 3/2. All right, let's do the z. 4 plus 1 is 5. That's a 5/2. I should have done this one with the plotter. So what do you get? You get 1/2, 3/2, 5/2. Let me see if I can do it real fast. If I can find the plotter. Okay, what was the first point? 3, 1, what? Come on, help me out. First point. No. What's the on the top of your page? 3, 1, 4. Okay, so there's the first one. What's the second one? -2, 2, 1. So there's the second one, right? And what did we end up with? 0.5. Was it 1/2? And what was the second one? 3/2. And what was the third one? So if all's right with the world, this will be between them. If all is right with the world. What was the first one? Grades. Well, let's see, can I change it? It's blinking. All right. Well, if we would have plotted the correct first point, they'd be nice and lined up. You guys, blindly. All right, homework is at the bottom of the page. Your quiz is tomorrow. Therefore, then I'll review on Wednesday, and your test will be Thursday. So quiz mañana. That Destiny breaks up over that. All right, sorry.